Okay, so for today, we're going to go over the quiz material for quiz 1. And all of this should be review, so if I'm moving quickly, it shouldn't be new material. So today we're going to talk about adding, subtracting, multiplying, and dividing positive and negative numbers, which is what we've been doing for a week. Okay, so this is what we want to do today. I want to review some key terms and concepts. I want to discuss the types of questions that will be on the quiz. And then I also want to practice some representative problems. So typical review stuff as we get ready for the quiz tomorrow. So first, let's go back to the very first day where we discussed what we mean when we say positive and negative numbers. Okay? And so we want to think of these positive and negative numbers in a way where we try to picture that a positive number, let's say positive x, is an arrow that points to the right, that's x units long. And then a negative number, negative x, is an arrow that points to the left, that's x units long. So positive numbers are right-facing arrows, negative numbers are left-facing arrows, and the length of the arrows depends on what the number is. So for example, negative 5 can be drawn as an arrow that points to the left, that's 5 units long. The negative means that it goes left, the 5 means that it's 5 units long. Positive 7 can be drawn as an arrow that points to the right, that's 7 units long. So, when we add two numbers, what we're actually doing is adding these arrows. We use what we've been calling a head-to-tail addition, which means we're going to stick the tail of one arrow on the head of the other. So let's look at this problem. Positive 2 plus positive 4 can be rewritten as an arrow that moves us 4 units to the right being added to an arrow that moves us 2 units to the right. Okay, so these are my two numbers, my 4 and my 2. And when we say that this is equal to positive 6, we mean that it's the equivalent of an arrow that moves 6 units to the right. So if I move 2 units to the right and then 4 units to the right, it's as if I moved 6 units to the right. Remember, we've been talking about these 2 and 4 as Legos that are put together to build a longer piece. Okay, so now let's look at positive 4 plus negative 2. We still want to think of two arrows being added head to tail. What makes this more complicated than our first question is that the second arrow moves us in the opposite direction. So the first arrow moves us 4 units to the right, and the next arrow moves us 2 units to the left. And if you watched me move 4 units to the right and then 2 units to the left, you would say that it is as if I only moved 2 units to the right. Okay, so a 4 and a negative 2 add together to create the equivalent of moving 2 units to the right. Okay, so these are arrow diagrams that show why 4 plus negative 2 is positive 2. Okay, now let's take something that's a little bit more difficult. 6 plus 2. It can be read as an arrow that points 2 units to the right, my positive 2, being subtracted from an arrow that points 6 units to the right. The problem is I want to prepare that arrow that points 6 units to the right, because I know I'm going to want to pull out an arrow that points 2 units to the right. So for all subtraction problems, you want to write the first number as 2 arrows, so that one of the arrows is what you want to take away. Now that should be in your notes multiple times, but that's an important step to do. For all subtraction problems, you write the first number, in this case the positive 6, as 2 arrows, so that one of the arrows is what you want to take away. So instead of positive 6, or this top arrow, you want to write it as the sum of positive 4 and positive 2. Now I'm not solving the problem yet. I'm not doing any subtraction. I'm just rewriting positive 6 as the sum of 2 other numbers, or I'm writing the arrow that points to the right, that's 6 units long, as the sum of 2 other arrows. And I picked these 2 specific arrows because one of the arrows needed to be positive 2, because that's what I know I want to subtract. Okay. Now I can take away the positive 2 arrow. So you can see that if the problem is positive 6, Okay, and what I'm left with is positive 4. Okay, I see a mistake down here. At the bottom of the screen, it should say positive 6 minus positive 2. That's what we've been doing. So this gets a little bit more complicated when we subtract numbers of different signs. So for example, if we're subtracting a positive number from a negative number, or a negative number for a positive number, because then the arrow picture we draw gets a little strange looking. Anyways, let's look at positive 5 minus negative 3. The first thing we do, like all subtraction problems, is we rewrite the first numbers so that it's made up of two numbers, and one of the arrows that it's made up of should be the arrow we're trying to subtract. So we're going to take positive 5 and we're going to make it negative 3 and positive 8. What we have here when we do this is we have still positive 5, but now it's made up of two arrows so that we have the negative 3 arrow which we want to subtract. Okay, so even though this doesn't look like positive 5 anymore, it still is, and we can subtract this negative 3 arrow now, which leaves us with positive 8. Okay, so on the quiz, you're going to have to do these problems. Let's look at some examples, and I want you to do these in your notebook, and then we'll go over them in the following slide. So let's stop for a second and practice some of these. So I'll give you some time to do them in your notebook. If you can do these 4 problems, and I want you to do arrow diagrams in order to show me the results or why these addition and subtraction problems are what they are, I want you to do the arrow problems for these 4. So go ahead in your notebook and do these 4 problems, drawing arrows for each so that you can show me that you understand what's going on in each of these 4 problems. Okay, so let's stop. Even if you're not finished, we can go over these. So let's do them one at a time. The first one, positive 3 plus positive 2, was the easiest. It should look like this. You should have an arrow that goes 3 to the right, and you should add it to an arrow that goes 2 to the right, and then you should show underneath how the equivalent is an arrow that moves 5 to the right. So your answer, if I ask you to do this on a test, should look like what I have here with my arrows. Okay, the second one, positive 3 plus negative 6, looks a little bit different. We start with an arrow that moves 3 to the right, and then starting our second arrow where the first one leaves off, we move 6 to the left. The arrow below shows that that's the equivalent of moving 3 to the left. So positive 3 to the right, negative 6 to the left, looks the same as negative 3, which is 3 to the left. Okay, so this next one is a little bit trickier because it's subtraction. So we take positive 5 minus positive 2, and we're going to try to prove that it equals positive 3. So the first thing I do is I rewrite positive 5 as positive 2 plus positive 3. So what I'm doing is I'm just rephrasing positive 5 so that it contains the arrow that I want to get rid of. Then once I write it out plus positive 3, I can get rid of the positive 2, which is what it means to subtract it, and I can show that I'm left with positive 3. Okay. The hardest one would be positive 5 minus negative 2. I take positive 5 and I rewrite it as positive 7 and negative 2. Again, that's just the equivalent of positive 5. Then I can subtract the negative 2 with the positive 7. So those are the 4 types, adding 2 positives, adding a positive and a negative, subtracting 2 positives, and subtracting a positive and a negative. Now let's go to the second part of what we looked at, which is the general statements about addition, subtraction, multiplication, and division. So the first general statement we looked at is that you should be able to prove that a positive plus a positive equals a positive. And if I asked you to do that on an exam, you would say, when read as an arrow statement, what you mean is an arrow pointing to the right is added to an arrow pointing to the right that has to end to the right of where you started. So you want to show that positive plus positive equals positive. I might ask what's called a sometimes, always, never question. So if I said positive plus positive equals positive, you would want to say always. A positive plus positive is always positive. Let's look at the next statement. A negative plus a negative equals a negative. This is very similar to the one just before this. First of all, you read it as an arrow statement, and then you explain that an arrow pointing to the left added to an arrow pointing to the left has to end to the left of where you started. So if this is what I'm asking you to prove on a test or on the quiz, you can literally just write that. An arrow pointing to the left added to an arrow pointing to the left has to end to the left of where you started. Also, a sometimes, always, never problem. For instance, I might say a negative plus a negative equals a positive, and then you would say never. A negative plus negative never equals a positive, because a negative plus a negative always equals a negative. Now, a positive plus a negative equals a positive or a negative. And if you wanted to explain that, you would say an arrow pointing to the right, which is what a positive is, added to an arrow pointing to the left, which is what a negative is, will sometimes end up to the left and sometimes to the right, depending on which arrow is longer. This would be a good one for a sometimes answer. If I said a positive plus a negative equals a positive, you would say sometimes. It sometimes equals a positive. If I would say a positive plus a negative equals a negative, you would also say sometimes. The next are the subtractions. The subtractions are related to the additions, and that's how we're going to solve them and prove them. So, for instance, a positive minus a negative equals a positive. And if I asked you to prove that, first you would translate the sentence to addition. And you'd use that rule, addition is subtraction of the opposite, and subtraction is addition of the opposite. This would give you a positive plus a positive equals a positive. And then you prove it using the arrow statements, which we did 2 slides ago. So you wouldn't stop at a positive plus a positive equals a positive. You would then go on to say an arrow pointing to the right plus an arrow pointing to the right has to end up to the right. Another pretty easy one is that a negative minus a positive equals a negative. So if I have sometimes, always, never with that statement, you would say always. And the reason why a negative minus a positive equals a negative is because if you translate it to addition, you end up with a negative plus a negative. And of course that equals a negative. And you could show that using arrow statements. So you would go on to say, this means an arrow pointing to the left is added to an arrow pointing to the left. And you have to end up to the left of where you started. And finally, there's a third subtraction. A negative minus a negative is sometimes a positive or sometimes a negative. And if you wanted to show that, you would translate it to an addition problem, which would give you negative plus a positive equals a positive or a negative. And then you would say when an arrow pointing to the left is added to an arrow pointing to the right, sometimes it's to the left and sometimes it's to the right of where you started, depending on which arrow is bigger. Okay, so there's addition and subtraction. Now let's do multiplication. The easiest one is a positive times a positive equals a positive. First, you translate it to an addition statement, and we'd use the rule which says A times B can be read as A is added to itself, B number of times. So we would say a positive number is added to itself a positive number of times, which we would then write as positive plus positive plus positive, which we can then turn into arrow statements and say an arrow that points to the right that is added to an arrow that points to the right, and so on, will always end up to the right of where you started. Another pretty easy one is that a negative times a positive is always a negative. So again, let's practice a sometimes always never statement. If I said a negative times a positive equals a positive, you would say never. A negative times a positive never equals a positive, because a negative times a positive always equals a negative. So again, to prove that a negative times a positive equals a negative, you first translate it to an addition statement. So we end up saying a negative number, that's my A, is added to itself a positive number of times, which is my B. And I can show that that has to be negative by writing out negative plus negative plus negative dot dot dot, which when we turn into arrow statements, we can read as an arrow that points to the left is added to an arrow that points to the left, and so on and so forth, and you will end up to the left of where you started. Okay, let's look at this next division statement. We have a positive divided by a positive equals a positive. So we know this is true because first you translate it to a multiplication statement. Remember, we use this formula A over B equals C becomes C times B equals A. And it's always helpful to keep track of what your A, B, and C are when you translate it. So when we translate it into multiplication, it becomes positive times positive equals positive. And from this point, it's easy. Now you'd want to keep going if this were a question on the quiz. The next thing you would say is you can read that as a positive is added to itself a positive amount of times. And then the final step is that means an arrow pointing to the right is added to an arrow pointing to the right, which has to end up to the right. So ultimately we proved that a positive divided by positive is always a positive. And finally, a negative divided by a positive is always negative. We go about the proof of this with the same process. So first we translate into a multiplication statement. Our A is negative and our B is positive. Our C is this other negative. So that becomes negative times positive equals negative. Okay, so the next step would be to say this means, if we use this A times B, means A is added to itself B number of times. Our next statement would be a negative is added to itself a positive amount of times. And then we would say this means an arrow pointing to the left is added to an arrow pointing to the left, and so on and so forth. And the only way you can do that is to end up on the left. Okay, let's look at something that we didn't do a lot of last week, but I want you to work on, and that's translating actual problems from division to subtraction. So for example, let's take 12 divided by 4 equals 3, and translate it to multiplication, then addition, and then subtraction. So to translate it from division to multiplication, we use this A over B equals C, becomes C times B equals A, and the new problem we get is 3 times 4 equals 12. Okay, that's the multiplication version of 12 divided by 4 equals 3. If we translate that into addition, our new 3 times 4 equals 12, A is added to itself, so 3 is added to itself 4 number of times. And so we get 3 plus 3 plus 3 plus 3 equals 12. And then finally for subtraction, we say addition is actually just subtraction of the negative. It's important to keep this first 3 as positive 3, because you're not adding and subtracting that 3, you're starting with that 3. And then every other addition sign we change to subtraction, so it becomes 3 minus, and then instead of positive 3 we get negative 3, minus negative 3, minus negative 3 equals 12. Okay, and you can go in the opposite direction too. You can go from subtraction to division. So if we take 2 minus negative 2 minus negative 2 equals 6, to translate into addition, multiplication, and then division, first we take Subtraction is actually addition of the opposite. So we change each subtraction to addition, and we change each negative 2 to positive 2. So we get 2 plus 2 plus 2 is 6. To change that into multiplication, we say A is added to itself B number of times. So we say 2 is added to itself 3 number of times to get 6. So it's 2 times 3 equals 6. And then division, we use the C times B equals A, and we switch it around to A over B equals C. So we get 6 divided by 3 equals 2. Okay, so let's practice some of these problems. These are the types of problems that you're going to see on the quiz. First, let's use the sometimes, always, never question. So for each of these 4 sentences, or each of these 4 problems, positive plus positive equals negative, you need to answer, is that sometimes true, always true, or never true? So for each of these 4, is the answer sometimes, always, or never true? Then I want you to prove, so using a long line of reasoning, prove why negative divided by positive is always a negative. And then finally, I want you to convert 8 divided by 4 equals 2 into multiplication, addition, and then subtraction. So we've done each of these problems just in this review. Now try to do each of these on your own. Okay, so I know 2 minutes is hardly enough time, but let's go over these answers. The answer for the first one, positive plus positive equals negative. Positive plus positive is never negative. Positive plus positive is always positive. So the answer for that would be never. The second one, positive plus negative equals negative, is sometimes. Remember, positive plus negative is either negative or positive. So some of the times, positive plus negative is negative. Negative times positive is always negative. That's the definition, and that's our general statement. So that's correct. And a negative divided by a positive is also negative. So those are the 4 answers you should have come up with for those 4 statements. For the next problem, where you're asked to prove why a negative divided by a positive equals a negative, okay, what you do is you convert it to a multiplication, and that gives a negative times positive equals negative, which could be read as a negative number is added to itself a positive number of times, which can be explained as an arrow that points to the left, when added to an arrow that points to the left, will always end up to the left. So that's why negative divided by positive equals a negative. And on the quiz, you basically want to write that out. You can draw arrows if you want, but you want to go through all of those steps. Make sure you get all the way down to the arrow diagram so that you're explaining the movement along the number line. And then finally, convert 8 divided by 4 equals 2 into multiplication, addition, and subtraction. Well, to take A over B equals C, multiplication becomes 2 times 4 equals 8. So that's my C times B equals A. That can be read as 2 is added to itself 4 times to get to 8. So 2 plus 2 plus 2 plus 2 equals 8. And then if we understand addition to be subtraction of the opposite, we've got 2 minus negative 2 minus negative 2 minus negative 2 equals 8. Okay, there are 3 more topics that I'm not going to cover in this review on purpose because I really want you guys to work on some skills that involve how you would prepare for it. But I don't want you to forget what it is that you have to cover. So in your review, and in fact, if you have a few minutes left today, you can start this with a partner. But I want you to also pay attention to the following 3 topics. I want you to try to explain to yourself so that if you're asked to on the quiz tomorrow, you can explain how to prove a negative times a negative equals a positive. Remember, we can't say a negative number is added to itself a negative amount of times because that doesn't make sense conceptually. So I'll give you a hint. You have to use the pattern of declining numbers, and that's something that should be in your notes, and I want you to review that. And because of that, it also is difficult to prove how a positive divided by a negative is a negative. Okay, that is just because the first step is to convert it to multiplication, which gets you a negative times a negative equals a positive, which is the hard one to prove. So we haven't gone over these 2 more difficult proofs, but I want you to brush up on that and cover it so that you can be ready for that tomorrow. And then I also want you to be able to discuss why 10, or actually any number, divided by 0 is undefined. And remember, we did the A over B equals C. We kept the C a question mark. And when you translate it into a multiplication problem, you'll see why it has to be undefined. Okay? So purposely I'm going to leave these 3 so that I don't do all the work of reviewing for you. And if you have a few minutes left and Mr. O'Brien says it's okay, you can get with a partner and explain how you would prove these 2 things and how you would explain why 10 divided by 0 equals undefined. Okay, so tomorrow is the first quiz. It's not a huge deal, but you want to get off to a good start. So make sure that you study, and make sure you study intelligently, which involves understanding what it is you already know and what it is you still need to know, and then studying those things that you still need to know. Okay, good luck. And I won't see you tomorrow. I'll see you on Thursday.